Okay, welcome to another session on M1 challenge questions. I stopped at this question in the last class, and I'm going to pick it up from here and try to do as many questions as I can with you. Let me just open up the marking scheme simultaneously so I can verify my answers as I go on. Some of these questions are tough, and we'll come across them in a bit. That's paper 4, November 22, 4-1. Yeah. Okay, test figure 6.1 shows particles A and B of masses 4 kgs and 3 kgs respectively attached to the ends of a light inextensible string. Passing over a small smooth pulley, the pulley is fixed at the top. Just a moment. Yeah. Okay. Okay. The pulley is fixed at the top of a plane which is inclined at an angle of 30 degrees to the horizontal. A hangs freely below the pulley and B is on the inclined plane. Uh, The string is taut and the section of the string between B and the pulley is parallel to the line of greatest slope. It is given that the plane is rough. So rough plane and are in limiting equilibrium. Find the coefficient of friction. So let's draw our forces quickly. That's 40. That's 30. You resolve that. That's 30 sine 30, which is 15. 30 cos 30, which is R. It's being pulled down, so frictional force is here. There is a tension here. There is a tension here. So at A, if I solve at A, t minus 40, 40 minus t equals to 0. Why? Because it's in limiting equilibrium. I could just say that 40 equals to t. At B, what's happening at B is that there are a range of forces. I can say that the balance is going to be T equals to FF plus 30 sine 30. FF is mu into R. 30 sine 30 gives me 15. 30 cos 30 plus 15. T is 40 from the situation above, and it gives me 15 root 3. So that's 25 divided by 15 root 3 equals to mu. Let's verify if I have the correct answer. 25 over 15 root 3. 0.962. Yeah, that's the correct answer. Now it's part. Okay. This is part B of the same question, and what we have here is a situation where it is given that the plane is now smooth and the particles are released from rest when the difference of the vertical heights of the particles is 1 meter. This is a slightly more challenging question, so look at this carefully. It says use an energy method to find the speed of the particles at the instant when the particles are at the same horizontal level. So it's moving a certain distance x and then being at the same horizontal level as b. So I'm going to take that line into account in a later calculation. Then it says use an energy method to find the speed of the particles when the particles are at the same horizontal level. So I'm bound to use an energy method. I cannot just simply do it with laws of motion, and it would be challenging with laws of motion as well. So what I am going to do is use an energy method, which means you have to use the work energy equations. So I'm going to start resolving the forces again. There's T and there's 40. Now at A, work done by, that's happening at A, by driving force should equal change in K plus change in P plus work done by resistive forces. So to be honest, in this question, nothing is driving the system because it's coming down because of gravity. So I'm going to write that as 0, half mv squared minus u squared. Change in P, so it's coming down, so I'm going to put a negative 410 mg, and h is x. So I'm assuming that it travels a distance of x. Now when I'm done doing the work done by resistive forces, there is a tension resisting this. Do I know this tension? Right now I don't. Can I still solve for this tension? Yes, it's simple. I can just start resolving the forces again, trying to construct equations and see what I get. So at A, what is happening is it's moving down, so 40 minus t equals to 4a, and then t minus again 30 sine 30, like in the previous part. There's no friction, so that makes the question slightly easier. Equals to 3a, so I get 40 minus 30 sine 30. Now what I want you to also notice in this question is that I find it easier to do the question, my calculator is in radians, do such energy questions with separate calculations for A and B. Why? Because they're moving in opposite directions. There is a solution where you get this in one standard direction as well, combined together a system as well, and you can look at those solutions. I can probably not do that right now because I've chosen to do this method. So that's 25 over 25 equals to 7a, a equals to 25 over 7. So 40 minus 25 over 7 equals to 4a, and no, sorry, 25 minus t equals to 4 times 25 over 7. It's 180 over 7 equals to t. So I have t, so I can use that as a resistive force, 180 over 7. And how much distance is it traveling? It's traveling a distance of x, like the entire particle. Then what's happening at B? Let's first construct this equation, then we're going to try to solve this. Work done by driving force, change in K, change in P, plus work done by resistive force. So change in K, okay, work done by driving force. So what's the driving force here? The driving force is T. How much distance is it traveling? That's the question that I want to answer now. So you notice that this distance is 1 minus x and this angle is 30. So what I'm going to do is I'm going to say that sine 30 is going to be 1 minus x over the distance that it's traveling. Sine 30 is half, so 1 minus x over d. So d is basically 2 minus 2x. So it's traveling a distance of 2 minus 2x on that triangle. So I'm going to say that the driving force is tension. So tension is 180 over 7. Let's write that with a red. 180 over 7. 2 minus 2x. Change in K, half 3 v square minus u square. M, G, traveling a distance of 1 minus x. No resistive forces because gravity is an internal force. You cannot count that as a resistive force, so that's 0. So let's try to then solve this. That's 360 over 7 minus 360x over 7, 1.5 v square plus 30 minus 30x plus 0. Okay, so I have solved this B equation first, so let's just shuffle that around. 360 over 7 minus 30, 150 over 7 equals to 1.5 v square plus 150 over 7x. Or is it minus? No, 35. Okay. So that's the equation at B. That's equation number 2. Let's look at equation number 1. It was 0 equals to 2v square minus 40x plus 180 over 7x. Can I simplify some numbers here? 180 divided by 7 minus 40, 100 over 7, so 100 over 7x equals to 2v squared. X is therefore 7 over 50v squared. Then can I substitute it into the other equation and see if I get a solution out of this? That's 150 over 7, 1.5v squared plus 150 over 7 into 7 over 50 v squared. I've replaced x with 7 over 50 v squared. So I get 3v squared, that's 4.5v squared equals to 150 over 7. 150 divided by 7 divided by 4.5 and then take a root. So I get v equals to 2.18, which is the final solution for this question. So slightly tough question. Make sure that you understand what has happened in the entire question and try to sort of replicate the process on your own to develop an understanding of this. Moving on to the next exam, let's look at some more questions. Let me see if I marked some questions. I don't think I have marked. Yes, I do. I have marked. This is November 22 4-2. Let's try to solve this question. Let me just open up the marking scheme simultaneously so that we can quickly verify our answers when we come across the question. That's November 22 4-2. Okay, this is a particle of mass 0.3 kg is held at rest by two light and extensible strings. One string is attached at an angle of 60 degrees to the horizontal ceiling. The other string is attached at an angle of alpha degrees to the horizontal. See diagram. The tension in the string attached to the ceiling is 4 newtons. So this is being pulled up by 4 newtons. There is a weight acting here, 3. Find the tension in the string which is attached to the wall and find the value of A. So let's call that T. Let's resolve this force. This is 4 sine 60 and 4 cos 60. If I'm resolving at this point, I will also then need to figure out T sine alpha and T cos alpha. So I do have two unknowns. I think this equation should solve. Let's call up equals to down. So 4 sine 60 equals to 3 plus T cos alpha, and left equals to right. So 4 cos 60 T sine alpha. Okay, 4 cos 60 should be 2 T sine alpha. So T should be 2 over sine alpha. 4 sine 60 is 2 root 3 from my calculator. T can be replaced with 2 over sine alpha into cos alpha. And that gives me 3 plus 2 over tan alpha. 2 root 3 minus 3 equals to 2 over tan alpha. So tan alpha is 2 over 2 root 3 minus 3. I'm trying to do it in exact numbers, which is why there's slightly more number of steps than you would expect on the on any solution. So tan inverse of answer gives me alpha is 76.9. Let me check if I've gotten that correct. Yes, I've gotten that correct. So T equals to 2 over sine 76.9 should give me 2.05. Okay, moving on, and let's see what other questions do I have marked here. I have question number 5 marked. Oh, this is precisely because it's a connected particles question. Let's try to do that, and then we'll do question 6, and I don't know if I need to do 7 as well. Yeah, I'll probably do 7 as well. It's a long question. So let's do question number 6 and 7. It says 3 particles. Now this is an interesting question. 3 particles A, B, C of mass is 3.3, 0.4 and m kgs respectively lie at a straight rest in a straight line on a smooth horizontal plane. The distance between B and C is 2.1 meters. So that's B, and that's C, and that's 2.1 meters. A is projected directly towards B with a speed of 2. After A collides with B, the speed of A is reduced to 0.6, still moving in the same direction. So B and C show that the speed of B after the collision. So this is just conservation of momentum. Let's do that. Conservation of momentum. So before equals to after. So before B is at rest, because it says it's there in the plane, lie at rest in a straight line on a smooth horizontal plane. So I can say that 0.3 into 2 plus 0.4 into 0 equals to 0.3 into 0.6 plus 0.4 into V. Let's try to solve that. This is a relatively simple question. That gives me V equals to 1.05. Then it says after the collision A and B moved directly towards A and B moves directly towards C. So B started moving. That's one thing that you need to be aware of. Okay, particle B now collides with C. After this collision, the two particles coalesce and have a combined speed of 0.5. So C, what has happened is B now started moving with a speed of 1.05 and then went on and collided with C, and they had a combined speed of 0.5. So again, I'm going to use conservation of momentum. I'm going to say that the mass of B was 0.4. So 0.4 into 1.05 plus m into 0 equals to 0.4 plus m into 0.5. That's conservation of momentum again. Gives me 0.42 and 0.4 plus m divided by 0.5. So that's 0.84. 0.4 plus m. M is therefore 0.44. Check if that's the correct answer again. Question 6. Yeah, that's the correct answer. It says find the time that it takes from the instant when B and C collide until A collides with the combined particle. So that's an interesting question. So what happened was that A and B sort of collided together. Then B started moving with a bigger speed. It started moving with 1.05 and A was moving with a speed of 0.6. That's what the question said initially, that its speed got reduced to 0.6. B then went on and collided with C and had a speed of now 0.5 when they were together, when their mass was basically 0.4 plus 0.44. What was A's mass? A's mass was 0.3. So now that since they are slower than A, what is going to happen is that A is going to come from the back and sort of collide again. But there is going to be a certain time lag. What would have happened is that while B was moving forward to collide with C, A would also have moved forward. So I first need to find out how much time it took for B to strike C, for B to collide with C. So its speed was 1.05. Time is what I want to find. Its acceleration was 0 and its distance was, in the question that says 2.1 meters. So I can then say that S equals to ut plus half at square. So that looks like 2 seconds. So what would have happened in those 2 seconds? A would have come forward. How much would it have come forward? 2 seconds. U equals to 0.6. A equals to 0. And what I want to find out is how far does it has it reached. So S equals to ut plus half at square. So it's moved a distance of 1.2 meters. So it's 1.2 meters ahead. There is only a distance when they collide. When B and C collide, A is just 0.9 meters away technically. So yeah, so A is 0.9 meters away. So now what is happening is that A has its going speed at 0.6 for combined particle. U equals to 0.5. There is no acceleration in both. They are going to collide at that instant. If this covers a distance of x, this must cover a distance of x plus 0.9 to cover up the difference. So again, S equals to ut plus half at squared. Because half at square is 0, so I just tend to write 0. So I have 0.5 t plus 0.9 equals to 0.6 t. 0.9 equals to 0.1 t. T equals to 9 seconds. What is the question asking you then? Find the time that it takes from the moment instant when B and C collide. So it takes how many? 9 seconds to collide. So you see these questions are getting tougher for momentum as well. So you need to think a little what's happening and where are those particles positioned. You won't get 5 marks just for using conservation of momentum. That's a 2-mark question. So make sure that you think about your answers. And let's do this last question number 7. It says a particle P travels in a straight line at a rest from point O. The acceleration of P at time t seconds after leaving O is denoted by A, where A is this. Find the velocity of P at t equals to 4. So velocity of P at t equals to 4 is basically integration, sorry, my bad. It started from rest, so I'm going to say that so V equals to 0.3 t power 3 over 2 divided by 3 over 2 plus C. So C is going to be 0 in this case. Why? Because I really don't need to think about the velocity. Because it's at rest. So I have V equals to 0.2 t power 3 over 2, 0.24 power 3 over 2. So I get 0.2 into 4 power 1.5. That gives me V equals to 1.6. Let me just verify if that's the correct answer. Yes, that is the correct answer. Okay, moving on. It is given that there is no change in the velocity of P at t equals to 4 and that the velocity of P at t equals to 16 is 0.3. Show that k equals to 2.6 and find an expression in terms of t for the velocity of P at for t is between 4 and t. Okay, so given that there is no instantaneous change and that the velocity of P at t equals to 16, so I've given you a coordinate. Show that k equals to 2.6. So I need to show this value for k is 2.6. So again, what I am going to do is I am going to integrate this equation again. Minus 3 over 2. V equals to minus k t power minus 3 over 2 plus 1 is half. So divided by half plus c. So V equals to minus 2k t power half plus c. And what I can then imagine is that there are two coordinates. One is that when t equals to 16, v equals to 0.3, and the other that I found out was when t equals to 4. This, since there's no instantaneous change, there's another coordinate 1.6. So I'm going to use both of these in order to find out the value for both c and k. It's going to be a set of simultaneous equations. Let's try to do that quickly. Minus 2k 16 power half plus c. I get that's 4 minus 8k plus c equals to 0.3. So that's one side of the simultaneous equation. 1.6 minus 2k 4 power half plus c. So that's minus 4k plus c equals to 1.6. Minus 8k plus c equals to 0.3 minus 4k plus c equals to 1.6. Invert the signs. So I get minus 4k equals to minus 1.3. K is therefore 1.3 divided by 4. It's not 13 over 40. No, I seem to have made a mistake somewhere. Let's quickly check. I don't seem to be spotting a mistake. Let me just check if my equations are correct. Okay, there are two negatives. Oh, okay, minus half, minus half. That's the mistake. And then that should give you plus 2, plus 2. So that's plus, that's minus. So those equations are wrong then. Let's try to construct them again. Since there's a negative half involved. So 0.3, that gives me 2 over 4, I think. So that's k over 2 plus c. And 1.6 equals to, it's also plus, I think that should be k plus c. So k over 2 plus c equals to 0.3. K plus c should equal 1.6. Eliminating c gives me half k. Minus half k minus 1.3, k equals to 2.6. Then for the expression, I can simply find the value of c. 1.6 equals to 2.6 plus c, so c is equals to minus 1. So the expression would therefore be, there's lack of space here because I've done a lot of working. So v equals to 2, k is 2.6, t power minus half minus 1. So that's 5.2 t power minus half minus 1. That's the equation for the expression of v. That's what the question is asking. Okay. Given that p comes to instantaneous rest at t equals to t, find the exact value of t. So instantaneous rest is when it comes down to 0. So 5.2 t power minus half minus 1. So 1 equals to 5.2 t power minus half. I can just take t power half to the other side by making it positive. So what's 5.2 squared? 27.04. It seems like a really large answer. But yes, that is the correct answer because the numbers are that way. Find the total distance traveled between 0 and t. 0 and t. So since the particle is not turning anywhere before that, I can just simply say that this is a question on integrating with limits. So I'm going to first integrate with limits from 0 to 4. And what equation am I going to integrate? I'm going to integrate this equation that I found, 0.2 t power 3 over 2, 0.2 t power 3 over 2. And then I'm going to add this up with 4 to 27.04. And what equation am I integrating now? I'm integrating 5.2 t power minus half minus 1. So that becomes 0.2 t power 5 over 2 divided by 5 over 2 with limits 0 to 4. And from this we get t power half divided by half minus t. So from here on, it's just a matter of making sure that you don't make a mistake in plugging in the numbers. The 0 would give you 0. Then I have 5.2 into 2 is 10.4. So 10.4 power 27.04 power half minus 27.04 minus, I'm very bad with limits, specifically because I ran out of space very quickly. 10.4 4 power half minus 4. So 0.08 into 4 power 2.5 gives me 8 over 5 plus 27.04 power 0.5 into 10.4. That gives me 54.08 minus 27.04. At 104 over 5. That's right, that is the decimal number as well. Okay, so 8 divided by 5 plus 54.08 plus 4 minus 27.04 minus 20.8. I am getting 11.84. I again seem to have done a mistake somewhere. I will have to figure that out. Let me check what I have done wrong. I think this number is wrong. It's 2.56. Check again. I think that was the only number that was wrong, which is why I try to punch in everything on a calculator as it is, rather than calculating the numbers, because I often get them wrong. Yeah, that was the only number that was wrong. So 12.8. That's the end of the challenge questions. Make sure to follow for more videos. I will be back with a few more questions later on in the day. Thank you.